Hello everyone, welcome in Cool IT Help. Guys, in this video tutorial I will tell you about the data structure algorithm, and here we are going to discuss about the selection sort algorithm. I have prepared a PPT to explain the complete information about the selection sort algorithm, and with the help of the example you will be able to understand the core concept of selection sort. If you know the selection sort base concepts, then you will be able to implement this algorithm in any language of your choice. So guys, let's get started. Guys, we'll start with this very first slide. Right now, as you can see on my screen, I have taken an integer array of size 6, and I have specified the index position from 0 to 5. You can see we have an integer array, and the array length is 5. So I am using integer variable n, which will store the length of this array. So we are going to sort this array in ascending order. Right now it is unsorted array. We have to implement selection sort algorithm on this array, and finally we will get a sorted array in ascending order. Now guys, we will move on the next slide. Okay guys, so in this slide, as you can see, in this slide we will understand the base concept on which this algorithm works. So you can see the complete array is divided in two parts. On the left hand side we can see a sorted array, and right hand side we can see unsorted array. This is the assumption before starting of algorithm. First step, we have to assume we have a sorted array on left hand side and we have an unsorted array on right hand side. Okay, so the 2 points you have to keep in your mind. The algorithm maintains two subarray in a given array because we have a problem. So with the array which is unsorted, so in the very beginning we have to assume this array in two parts. First part is sorted and we will assume the remaining part is unsorted array. And the algorithm works like it repeatedly finds minimum element in unsorted array. Once we found any smallest element, then we will put in the sorted array. That means we will put on the left side array, we will replace the element. I will explain you this concept in the next slide. Now going to the next slide. As you can see, here we will understand the core concept. What are the basic 4 points that you have to remember? Okay, so these points will help you to implement this algorithm in any language. So you have to remember these 4 points. This is the base, this is the soul of this algorithm. So we have a problem. We are going to sort this array in the ascending order. To do this, we have to remember first point. So very first we have to assume the first element as the smallest element in this array. We are just assuming, okay, and it will remain in sorted array. So our sorted array has only one element. You can see this is the sorted element. We assumed this is the minimum element of our array. So point 1 is saying we have to assume the first element as the smallest element. Okay, and it will stay in the sorted array logically. Okay, now the second point, we have to store the index position of this element. So we have created a variable min and we have stored its index position. That means we have assumed that 4 is our smallest element and its index is stored here in the min variable. So we are using min variable to store the index of the smallest element. Okay, so now as you can see, so the array min, if you want to get the value at index 0, so you have to use this notation. So you will get the value 4 at index 0. And guys, the third point, in the third point, then find the smallest element in the unsorted array. Okay, so we have to start from the index 1 and we will look for a smallest element which is smallest as compared to our very first element. Okay, so the third point is saying find the smallest element in unsorted array by comparing with array min. That means it is saying we have to compare with the very first element. Okay, in the fourth point, once we find any smallest element in unsorted array, so we have to store its index immediately inside the min variable. You can see. Okay, I will show you the execution of algorithm in next slide. So we going on the next slide. Okay guys, so here is the first execution of the algorithm. So first we will understand what we have on this slide. Int min is equal to 0. As you can see, we have a value 4 at index 0. We have assumed this is our minimum smallest element. This is our smallest element. Okay, now the point second is saying we have to start comparing the unsorted element with this. Okay, so here is the line. We assumed first element as the smallest element and we have stored its index in min variable. Okay, now what we have to do, we have to pick the very first element. You can see this red mark. This is pointing to the index 1. So we will start from the index 1 because our unsorted array is starting at this index. Okay, so I is equal to 1. That means we are at this place. So we picking up this element for the comparison. You can see this code, if array I less than array minimum, that means we are comparing 2 with 4. So 2 is less than 4. Then we will go inside this if condition and we have to store the index of this smallest element. Min is equal to 0. Okay. So in this case, min variable is updated. Now the min variable becomes 1 and the minimum variable value is 2 right now. Okay, and we will move on the next because we have other elements as well in this array. So we have to check that this element is smallest or we have any other element is smallest than this element. So we are going to the next slide to see what is the next step. Okay guys, so in the previous step we found 2 is the smallest element. We have stored the index, its index. Okay, and the pointer will move to the next for picking up the next element. Okay, now the comparison will happen between 2 and 15 because we have changed the min, because array min is now 2 and min is equal to 1. So the value will be compared. 15 is less than 2, so it is false, and if condition will not executed and we will move further. So pointer will move to the next element. Now we will check, we will compare with this 22. Okay, and previous condition has not changed the index of min. So right now we have a array min is equal to 2. So the comparison will happen between 2 and 22. So 22 is less than 2, which is false. No change will happen. Now we will move to the next. And now you can see the 7 will be compared with the 2. Okay, so array minimum is still 2. There is no change. Okay, so this condition will be executed, the comparison will occur, and 7 is less than 2, which is false, and no change will occur. Now we will move to the next. Now the pointer moved to the 5th index. Okay, and again the comparison will be happen. So 1 will be compared with the 2, so we found another smallest element. Okay, so if condition will executed and min is equal to I. Okay, now the smallest element will become at 5th. So we have stored the index 5th. Now min variable is updated. Okay, min is equal to 5. Okay, now array min value is 1 because min is updated, and index 5th index is stored in the min variable because we found the smallest element at 5th index. Okay, now the swapping will occur. Now I will show you the next slide. Once we found the smallest element, we have to swap the element in the unsorted array. Okay, so we found our very smallest element, and 1 will be go at 0 place and 4 will come to the 5th place. So the swapping will happen. Okay, you can see I have given array min value is 1. We found the smallest element at index 5. Okay, now we have to swap the element at 5th position with the element at 0th index position. Okay, so swapping will occur and 1 will come to at 0th index and 4 will reach at 5th index. Let me show the next slide. Okay, so you can see that swapping is done. 1 is here, 4 is here. So we got our first sorted element, smallest element among all these elements. Okay, now the loop will execute and we will again repeat the same process for the other elements as well. Let me show you how it will go. Now see this. Now again min pointer will be moved to the 1 because we have our sorted array which has element 1. Now we have to assume that 2 is our smallest element. So we are now assuming min is equal to 1 is the smallest element, and the comparison will start from the second index 2, 3, 4, 5. Okay, so all these elements will be compared. Okay, so as you can see, we have no other element which is smallest than 2, so no change will happen, and two will be remain as its position. Okay, now again we will repeat the same process. Now 15 will become the smallest element and we will store its position at min variable. Okay, min variable, so array min become 15, and now the comparison will start from the third index 3, 4, 5. So first we will compare the 22 with 15, no change, and we will check the 7 with the 15. So we found the 7 is the smallest element. Okay, now min variable will be updated with the 7, and further the comparison will occur with the 5th in the next iteration. So 7 will be compared with the 4. We found the 4 is the smallest element in the unsorted array, and this 4 will be finally swapped with the 15. Now 4 will come at place of 15th and 15 will reach at place of 4. So swapping will occur. Okay, now you will see the resultant array 1, 2, 4 which is in sorted, and remaining unsorted elements is 22, 7 and 4, 15. Now we will see the next slide. Now guys, you can see now again the position marker is reached at third index, and now we'll assume 22 is our smallest element, and the comparison will occur with the unsorted array elements which is 7 and 15. So first the comparison will occur with the 22 and 7. So we found the 7 is the minimum element. Okay, and again we will check 15 is also greater than with 7, so 7 will become our smallest element, and the swapping will occur between 22 and 7. Okay, so it will be swapped. You can see the resultant array. So 7 will be reach at third index and 22 will reach at fourth index. You can see, so we have sorted element up to third index. Okay, now we'll move to the next slide. You can see again the pointer will reach at fourth place, at fourth index. So here we will assume that fourth index value is the smallest. Okay, now the comparison will happen with the remaining unsorted array element on the right hand side. So we have only one element in unsorted element, so the comparison will occur, and we found the minimum element. So swapping will occur between these two elements. So 15 will reach at fourth index and 22 will reach at fifth index. Okay, in this way you will get the resultant array 15 and 22. Now this marker will reach at fifth position because we have no other element in unsorted array on the right hand side, and our sorted array is grown and it is perfectly sorted, so no other swapping will occur, and fifth position element will remain at the same place because this is the largest element among these elements. Okay, so we found the sorted array, at last. Okay, you can see finally we achieved the sorted array. So guys, this is the way algorithm works. So we have to focus on these 4 points. I will show you the code of the algorithm. Okay, so I have written the I have implemented this algorithm in the Java, so I have prepared an example. You will see the code in the next slide and I will explain you those as well. So guys, on this slide we will see the implementation of the selection sort algorithm in Java. So right now I have written the code of selection sort in Java. So this is very clear, this is very easy. We have used two for loops. The external for loop that will put the pointer on the very first element, and we will assume that our first element is the smallest element, and we have one min variable to store the index of the smallest element. Here we have the array on which we are performing the sorting, and this is the length of the variable. So we have stored the length of array here. Okay, and now internal loop will work. So internal loop will compare the unsorted elements to find the smallest element. So every time when we found any smallest element, we are storing the index of that element. Okay, and we are moving. Once we found, the index is stored. Now the loop will go on and we will compare the other elements as well. Suppose we found the very smallest element at the last of the main array, then the index of that element will be stored here in this min variable. So after finishing the for loop, we will come here, the swapping will occur. So we have found the smallest element and that will be placed to the very first inside the array. So we will place our smallest element in the very first position of the array. So the swapping will occur. Okay, in the same way, once we external loop completing its one iteration, then we will get our first element, which is sorted element, that will be placed inside the sorted array. Now the external loop will point to the next element, that means the second element of the main array, and it will be assumed this is the smallest element of the array, and the internal for loop will start comparing from the third index to the fifth index, and it will try to find the minimum element in the remaining elements. Suppose if we found any smallest element, that index will be stored here, and once we complete the for loop, and then the swapping will occur. So the found minimum element will be swapped with the very first element, which we have assumed the minimum element. So the same loop will keep go on, and finally we will get our sorted array. Let me show you the Eclipse. There you will able to understand this code very easy. So guys, here is the Eclipse. This is the Java implementation of the selection sort algorithm, and the code is very clear and this is readable. I have given the comments here. So this is the selection sort, this is our class, and here we have declared one variable min, which is going to store the index of the smallest element. Okay, this is the I for the for loop, and we have one array which is integer array. Okay, and we have storing the length of array in this variable n. Okay, and this is our internal loop. So internal loop is running up to the n, the length of the array. So we are going at this going at the index 5th, 0 1 2 3 4 5. Okay, and we have the if condition to compare the unsorted array elements with the assumed minimum element. Okay, suppose if we found any smallest element, we will store its index. Okay, so after finishing inner loop, okay, you will get a smallest element index. Then we have to place our element in the sorted array. That means swapping will occur. So our as an example, in the first iteration the swapping will occur. So we found the smallest element at 5th place, so swapping will occur between 1 and 4. Okay, let me run this example and that will be more clear for you. And guys, you can see the result. So in the first iteration of the external loop, the swapping occurred between 1 and 4th. Okay, because initially we have assumed that 4 is our smallest element, and the internal loop start comparing from 2, okay, and then 15, 22, 7 and 1, and finally we found the minimum element at this place. So the swapping occurred between 1 and 4. So in the first iteration of the external loop, we will get our sorted element. In the second iteration of the external for loop, we will get another sorted element. Okay, in the same way, in the third iteration, we will get our third element in the sorted array, and we will get fourth element in the next iteration, and in the same way we will get another element in the next iteration. So the algorithm is working in this way. I hope this algorithm is clear to you guys. If you have any doubts, so please comment. I will try my best to reply as soon as possible. And guys, if you found this video useful, so please like this video and don't forget to subscribe. If you subscribe, I will bring more useful videos for you on data structure. So guys, for now, thanks for watching Cool IT Help.